All right. I'm going to go ahead and answer the following question. A new basketball player has a 25% chance of hitting a three-point shot in a game. Suppose she is the all-star of the team and gets 5 shots per game. On a separate sheet of paper, create the probability model. So I'm going to go ahead and show you how to do that. So let's take a look over here. We are told that the n is 5, which means she's going to take 5 shots. So that's our sample size. She has a 25% probability of making a shot. So that is her success. And that means she will miss a shot 75%. All right. So because her sample size is 5, I'm going to go ahead and use the binomial theorem without even looking at the formula. I know that I'm going to use Pascal's triangle in the 5th row because our sample size is 5. And if you remember how to do that, every row starts with a 1, ends with a 1. And the number, the sum of the two numbers above is the number below. So I'm going to use the 5th row, which is 1, 5, 10, 10, 5, 1. And using a probability model, she's either going to miss 0, so she misses all 5 shots, or she'll make 1, or she'll make 2, or she'll make 3, or she'll make 4, or she'll make 5. So we can call the making a shot X, and this will be P of X. Now, obviously, I didn't create enough space here, but this is how we're going to write down our probabilities. So the first thing I'm going to look at is Pascal's triangle. The first way of making 0 shots, that means she's going to miss all 5, and that means 0.75 cubed because she won't make any shots here. Sorry, not cubed, to the 5th. Since our sample size is 5, she will be making 5 shots. The next one is she's going to, there's 5 combinations of making 1 shot. So that means I'm going to put a 5 times 0.75 to the 4th times 0.25 to the 1. Now I'm putting the 1 here to show you that the degrees always add up to the sample size, which in this case is 5. The next one is going to be 10. That means there's 10 ways she can make 2 shots. So that means 0.75 cubed times 0.25 squared. And you can see how the pattern's going. 0.75 is decreasing by 1, and 0.25 is increasing by 1. So the next one will be plus, and I'll write it down here, 10 again. She is missing 2 shots, but in this case, she's going to make 3 shots. Plus, the next one will be 5. She's going to miss only 1 shot, but she's going to make 4 shots. And the last one will be 1, which means there's only one way she can make 5 shots in a row. So if you look at all our probabilities, and plugging it into the model, 0 shots would be this one here. There's one way that could happen. 1 shot would be this one. So this is the probability of making 0 shots is this. The probability of making 1 shot is this. The probability of making 2 shots is this. You could see success is twice, failure is 3 times. Here success is 3, failure is 2. Here success is 4, failure is 1. And here success is 5, and there is 0 failure. And in front of each one is the combinations. In other words, how many ways that can occur. So there's many ways this questions can be asked now. For example, if I said, what's the probability of making more than 4 shots? Then you would add up the probability of 4 successes and 5, and so on.